The quadratic formula is used when you have a quadratic that can't be factored, or if you don't like to factor and you'd prefer to use a formula each time. When you're using the quadratic formula, you must be set equal to 0 and in the form where you have ax squared plus bx plus c. Your x squared term is first, then your x term, and then your constant. If you are in this form, then the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. This expression under the square root, the b squared minus 4ac, is called the discriminant. The discriminant is going to tell you what types of solutions you have. It's also going to determine the unique way that each problem is solved. So let's take a look at the first one. We can see in this first problem it's in the right form and it's set equal to 0. If you want to, you can say that your a value is 1 because that's the understood 1. Your b value is 3 and your c value is negative 7. Then we're going to plug into our formula to solve for x. X equals negative b, which is 3, plus or minus the square root of b, which is 3 squared, minus 4 times a times your c, all over 2 times a. All right, so that's going to tell us that x is negative 3 plus or minus. Now, draw your square root house, then go to your calculator and type in the discriminant. Type in what's underneath the house. Type that in exactly like you see it on your calculator. Use your parenthesis buttons here because this is squared. So open a parenthesis, 3, close a parenthesis, squared, minus 4 times 1 times negative 7. And when you do, you're going to get for your discriminant this time 37. All over 2 times 1 is 2. Now, this 37, what's under the radical, is going to, as I said, determine how we solve the problem. 37 is not a perfect square root. It is not a radical that can be broken down, so therefore there's nothing else we can do and our problem is complete. Now, every once in a while, usually if it's a word problem, your teacher might want the answer as decimals. If that's the case, then you're going to break off into the positive and you're going to break off into the negative. The positive says negative 3 plus the square root of 37 all over 2. And then you'll have negative 3 minus the square root of 37 all over 2. Just go to your calculator and say negative 3 plus the square root of 37. You'll get like 3.08 rounded, divided by 2, and you'll get 1.54. And that's if your teacher wants it that way. Then you'll go negative 3 minus the square root of 37. Hit equals to get that decimal to a couple places rounded. It's negative 9.08 divided by 2 equals negative 4.54. Like I said, usually that's only if it's a word problem. Maybe it's time and you want to know it was 1.54 seconds, that kind of thing. All right, let's take a look at the second one. All right, it's in the correct form, so we can look at it and see that our A value is 10, our B value is 3, and our C value is negative 1. So here's our formula over here. I have it over there until you get it memorized. X is equal to negative B, which is 3, plus or minus the square root of parentheses B squared minus 4 times your A times your C all over 2 times A, which is 10. So that's negative 3 plus or minus. Now, draw the house, but go to your calculator and type this in perfectly to see what lives at your house or what your discriminant is. And so when I type that in, I'm going to get 49 all over 2 times 10, which is 20. Now, this particular time, my discriminant, or that 49, is a perfect square. The square root of 49 is 7. So therefore, we have negative 3 plus or minus 7 over 20. In this particular instance, we need to solve it because those are like terms and we can collect those and we should collect those. We're going to say negative 3 plus 7 over 20. So that's negative 3 plus 7 is 4 over 20, which reduces to 1/5. And then we're going to say negative 3 minus 7 over 20. So that's negative 10 over 20, or negative 1/2. When you have your answers to come out nice numbers, that just means that the original trinomial could have been factored. All right, example 3. On this example, we're not set equal to 0. So that's the first thing that we need to take care of. So add x to the other side. Make sure that you write it in the correct order, which is decreasing order. We want 2x squared first, plus x plus 4 is equal to 0. All right, use your formula, and if you want to, we'll say that A is 2, B is 1, and C is 4. A, B, C. All right, use your formula. X equals negative 1, which is B, plus or minus the square root of B, which is 1 squared, minus 4 times A, which is 2, times C, which is 4, all over 2 times A. All right, so negative 1 plus or minus, draw the square root. Now go to your calculator, type that in exactly as you see it so that you can see what your discriminant is or what's the value under the radical. And this particular time, I get negative 31 over 2 times 2, which is 4. All right, this particular time, my discriminant is negative. What that means is that I have imaginary solutions because, if you'll recall, you can't take the square root of a negative number. So you're going to pull out the imaginary unit, which is the negative that's under the radical, and leave the 31 as it is, all over 4. If 31 was a radical that could be broken down or simplified, I would, but in this case, I can't. So we just leave it alone. All right, let's look at example 4. In example 4, we're not set equal to 0 yet, but that's the first thing we'll do. So subtract 6x, come over here and subtract it over here. Add your 4, so plus your 4. So I'm left with 0 on this side. And over here, write it in the correct order, x squared minus 6x plus 4. Now, if you'd like to, you can tell yourself that A is 1, that understood 1. B is negative 6. And C is positive 4. And then we're going to use that quadratic formula, so let's plug it in. It's going to say x equals negative B, which is a negative 6, plus or minus the square root of B, which is negative 6 squared, and it's really important to put that in parentheses, minus 4 times A times C, all over 2 times your A value. All right, right here, negative of a negative turns into a positive 6. Two wrongs make a right, only in math class. And then plus or minus the square root. All right, let's go see what lives under our house or under the radical or what the discriminant is. Type that in exactly as you see it. When you do, you're going to get 20. So we get 6 plus or minus the square root of 20 all over 2. All right, this time our discriminant is 20. So we have to think, how do we deal with the square root of 20? And what we want to do is that is a radical that can be broken down. So to simplify that radical, and if you're not sure, I have a video that you'll be able to watch, another video to help you with simplifying radicals, but we'll do the short version here. Remember that you're trying to find a perfect square that goes into 20. So 4 times 5, so I'll say the square root of 4 times the square root of 5. And the square root of 4 is perfect, and you get 2. So you have 2 on the square root of 5. So then I have 6 plus or minus 2 on the square root of 5 all over 2. But you know, actually, there's one more thing we can do. We can reduce. We can simplify or reduce. If there is a number that goes in this, this, and this, not the house, not what's under the radical, that's a separate type of term, but it's just like reducing fractions. So you're allowed to cancel only if it's in all three. You can say 2 in there once, 2 in there once, and 2 in there 3 times. It's a little shortcut if it's in all three. If it's not in all three, don't do it. So you have 3 plus or minus. I don't know if you want to put the ones or not. That's completely based on what you're comfortable with. So you can say that, or you can say that. They're both the same thing. Okay, let's look at example 5. In example 5, we're looking first to see that we're not set equal to 0. So let's do that. So add your 5 over. So I have x squared minus 4x plus 5 is equal to 0. All right, if you'd like to, pause the video, put it in the formula, and get all the way to see what the discriminant is, or whatever's under the square root. All right, so our a value is 1, our b value is negative 4, and our c value is 5. So we'll say x equals negative of a negative 4 plus or minus the square root of b, which is negative 4 squared, minus 4 times your a value of 1 times your c value of 5 all over 2 times 1. Again, 2 negatives make a positive, plus or minus. Now just draw the square root, just draw the house. Now see who lives at your house. See what the discriminant is. Just go to your calculator and type that in perfectly using your parentheses, and you'll say parentheses negative 4, close the parentheses, squared minus 4 times 1 times 5. And when you do, you get negative 4 all over 2. Okay, this is another scenario where the discriminant is negative. So basically what makes each problem different is deciding what you're going to do with the square root there. In this particular case, because it's negative, I have to pull out the imaginary I. You can't have a negative under a square root. So 4 plus or minus, pull out your I. And now you just have a 4. Well, the square root of 4 is perfect too. So you get 2i all over 2. And if imaginary numbers are difficult for you, again, there'll be a video on imaginary complex numbers you could look at. And then here's another situation where I'm allowed to cancel. And so a 2 goes in there 2 times, 2 goes in there 1 time, 2 goes in there 1 time. So my final answer is 2 plus or minus 1i over 1, or you can just say 2 plus or minus I. Okay, let's take a look at example 6. Example 6 is already in the correct form, so we're ready to go. A is 12, B is -5, and C is -2. So let's use our formula, and if you'd like to, pause the video and try it yourself, and then start it back to check. So x is equal to negative b, which is -5, plus or minus the square root of b, which is -5 squared, minus 4 times 12 times -2. That's your b squared minus 4 times a times c, all over 2 times a, which is 12. All right, so then we're going to say again, those two wrongs or those two negatives make a positive. So 5 plus or minus. Okay, let's go to the calculator and see what the discriminant is going to be this time. So I'm going to just draw the square root, go to my calculator, and type it in just like I see it. If you do that and do it correctly, make sure you're using your parenthesis buttons, you get 121 all over 2 times 12, which is 24. All right, again, it's this number right here that helps me to determine the rest of the problem. This is a perfect square. You can take the square root of 121, and it's 11. So just 11. The square root is gone because you took the square root. Equals, now break off into your two things. Go to the positive and go to the negative. Go to the plus and go to the minus. 5 plus 11 over 24. And that's going to be 16 over 24, which reduces to 2/3. And then you'll say 5 minus 11 over 24. And so when you say 5 minus 11, you get -6 over 24, which reduces to -1/4. You want to always reduce your answers. All right, last one. So on this one right here, the first thing we want to do is obviously get it in the correct form. So let's subtract our 10x from both sides. And you have 4x squared minus 10x plus 25 is equal to 0. Pick out your A, B, and C. And again, pause the video if you'd like to try it yourself to see. So here we go. X is equal to negative of a -10 plus or minus the square root of b, which is -10 squared, minus 4 times your a, which is 4, times your c, which is 25, all over 2 times a, which is 4. All right, so again, the two negatives turn into a positive. All right, draw the square root house and then see what lives under the house, or go to the calculator, basically type it in perfectly, and you're looking for your discriminant value. So if I type in -10 in parentheses, if you don't put the parentheses, you'll miss it. So be so careful. Squared minus 4 times 4 times 25, and you'll get -300 all over 8. Okay, this time our discriminant, it's negative. So we're going to pull out the imaginary unit I because you have a negative under a square root. And also, you're going to have to simplify or break down the radical. So I will have 10 plus or minus, right? We're going to pull out the I because of the imaginary. Now, the square root of 300, if I come over here, I know there is a perfect square in there. That could be rewritten as 100 times 3. And the square root of 100 is perfect 10. So that crosses out, and just bring that down. And you get 10 square root of 3 all over 8. And if you notice, this is another one where I can reduce. There's a 2 that goes into all of them. Now you can only reduce if it goes into all 3. So 2 goes in there 5 times, 2 goes in there 5 times, and 2 goes in there 4 times. And I get 5 plus or minus 5i square root of 3 all over 4. And that's your final answer. If you need more help or practice on the quadratic formula, be sure to watch my practice worksheet on this topic. There you can watch me work more examples. You can pause the video, try the problem on your own, and then come back to check your answer. Again, if this video was helpful, please like and subscribe to the channel and maybe even share it with a friend. This allows me to continue to grow the channel. See you next time.